In this video, we'll generate the exponential decay curve and exponential saturation growth curve using EXPON.DIST. We'll use the values of x from 0 to 1.8, and our lambda will be data validation on the range starting 0.3 to 1.8, and save. And these are the values for lambda. So starting with 0.3, our value for EXPON.DIST will be array formula EXPON.DIST of the x values, comma, lambda, comma, 0, which is the probability density function, also known as the decay function. And we divide this by lambda. To match with the other values, the other data set. Next, we generate the decay, which is array formula, exponent of the x values. And because there's a negative sign, negative lambda, so we multiply this by lambda. So times lambda. And there's a negative sign. So put in a negative sign. So they have the same trend line equation, and they're on the same trend line. Next, we generate the exponential growth, which is array formula, EXPON.DIST of the x values, comma, lambda, comma, 1, because this is the cumulative density function. Then that's in yellow. And we generate the same saturation using exponent. So this is equal to array formula, exponent of the x values. And there's lambda. So we factor in lambda. So times lambda. And there's a negative sign. So we factor in the negative sign. And finally, that's 1 minus exponent. So 1 minus exponent. Now they're on the same trend line, and they have the same trend line equation for the saturation. Now we change lambda to 0.6. This is the decay, and this is the saturation. Lambda equals 0.9. So we have the decay and the saturation growth. Our lambda is 0.9. So that's 1 times e to the minus 0.9 x. And lambda equals 1.2. So we have our decay and the saturation, yellow and green. And lambda equals 1.5. So this is the decay, and this is the saturation. And finally, lambda equals 1.8. So this is the decay approaching 0, and the saturation approaching 1. This completes the use of EXPON.DIST, array formula, and exponent function to generate the exponential decay and exponential saturation growth models.